All right, let's proceed. I'm going to start kicking in here to number 53. Okay, number 53. Sine theta over sine theta minus cosine theta equals 1 over 1 minus cotangent theta. All right, which side looks more complicated? Maybe the left, but if I do the left side, I'm not quite sure what I'm going to do because everything's in terms of sine and cosine, other than maybe multiply the top and bottom by the conjugate of this. So multiply top and bottom by sine theta plus cosine theta. If I do that, I'm not sure how I'm going to get to this. Sure, it could work out, but let me start with this side. I'm going to go ahead and rewrite this as 1 over 1 minus cosine theta over sine theta, because that's what cotangent is. Then I'm going to get a common denominator between these two. So 1 over, I'm going to have sine theta over sine theta again, and then I'll put them together, so it's going to look like this. So that's what happens when I put these two together. And that's 1 over a fraction. Oh, I'm there. Okay. So 1 over a fraction, just reciprocate it. Sine theta over sine theta minus cosine theta. And I'm done. Well, that was nice. Glad I started with the right side. Okay, number 57. For 57, we have, and we are recording, yes, okay. Cosine theta over 1 minus tangent theta plus sine theta over 1 minus cotangent theta equals sine theta plus cosine theta. All right, obviously the left side's more complicated. And man, well, I think I'm going to do what I just did a second ago. I'm going to go cosine theta over 1 minus sine theta over cosine theta. That's just me rewriting what tangent was. Plus sine theta over 1 minus cosine theta over sine theta. So cotangent is this. I'll get common denominators in the bottom. So I have cosine theta on top still. Then this becomes cosine theta minus sine theta over cosine theta. So all I did there was put these two together. I did cosine over cosine here, put them together. Here I'm going to do sine over sine and put them together. So I should have sine theta over sine theta minus cosine theta over sine theta. And boy, let's do a reciprocal. So let's keep in mind here that this cosine theta on top is really like cosine theta over 1, and this sine theta on top is really like a sine theta over 1. And so I have a fraction over a fraction, so I flip it. So I've got cosine theta over 1 times the reciprocal here, cosine theta on top. And on the bottom I have cosine theta minus sine theta. Then plus sine theta over 1, and then times sine theta over sine theta minus cosine theta. All right. Okay, I think I see what might happen here. This is going to be cosine squared theta over, so I put those two together, cosine squared theta over cosine theta minus sine theta. Then plus, here I've got sine squared theta on top over sine theta minus cosine theta. Man, these are almost the same denominators. If they were, I could put them together, and then this would be this plus this, which would be 1, but it's not. The only way to make these two look the same is to factor a negative out. So if I take a negative out of here and here, this will become negative, that will become positive. So let me pull that negative out. It's going to become positive here, and that'll become negative here, but then the negative came out, so that'll be a minus there. Now the denominators are the same. I know they're not ordered the same, but they are the exact same thing. So that now becomes cosine squared theta minus sine squared theta over the common denominator, which is now cosine theta minus sine theta. I see it. All right, the numerator is a difference of squares. It's, you can rewrite the numerator as cosine theta plus sine theta over cosine theta minus sine theta. And that's all over cosine theta minus sine theta. And these two factors cancel. And all you're left with is cosine theta plus sine theta, which is this. Now that was a good one. I like that one. I don't see how you could start with the right side and get to that. I'm also tempted to try something else, but I got it, so I'll just let it be. 57 is done. 61. Ooh. Tangent theta plus secant theta minus 1 over tangent theta minus secant theta plus 1 equals tangent theta plus secant theta. Oh man, that looks like a disaster ready to happen here. Well, when you're in doubt, let's just turn everything to sine and cosine, I guess, on the left side and hope for the best. All right, so we've got sine theta over cosine theta plus 1 over cosine theta minus, so I just rewrote this sine over cosine, 1 over cosine, and this one's minus 1, and then over, same thing, sine theta over cosine theta, but this time minus 1 over cosine theta, and then plus 1. So what I'm going to do now is going to be a little bit interesting. I guess I haven't done this yet. I'm going to multiply the top and bottom by cosine theta. So it's going to distribute here, here, and here. It's going to distribute here, here, and here. And remember, when it goes in, this cosine theta is going to be on the top. Okay, so it's going to be cosine theta, sine theta over cosine theta. Then you're going to have cosine theta over cosine theta. Then you're just going to have cosine theta. So when I do that, here to here, the cosines cancel. All I get is sine theta. When I go here to here, all I get is 1, plus 1. And when I go here to here, I get minus cosine theta. Then over, now the bottom, same thing, cosine through here, I get, the cosines cancel, so I get sine theta minus 1, and then plus cosine theta. Ooh. This does not look good. Let me make sure I wrote this down right. Tangent theta plus secant theta minus 1, tangent theta minus secant theta. I'm a little bit stuck here. This is good. I've got everything in terms of sine and cosine, but it doesn't look any easier. I can't multiply by like a conjugate or anything because I have 3 terms, not 2. Man. Thinking of maybe taking a different approach to this. I'm going to leave that on the board in case I need it. But I've got this other idea. I don't think it's going to work, but let me see here. What if I do this? What if at the beginning I try and create this guy here up top? So let me explain what I mean by that. These tangents are the same, so I can do tangent theta. And then what I'd like to have is a minus secant theta up there. So what if I do minus secant theta, and then over here I'm going to say plus 2 secant theta. And I think I will get rid of this for now. So do you agree? Let me put the denominator down here. I have tangent theta minus secant theta plus 1. That's my denominator. I'm trying to get this up here. So what I did is I said I have a plus secant theta. So I can write that as minus 1 secant theta plus 2 secant thetas. If I put these two together, I get that. But this and this match. And then I have a minus 1 up there. I'd like to have a plus 1. So if I say plus 1, then I would have to say minus 2 out here. Right? So plus 1 minus 2 is minus 1. And then the minus secant theta and plus 2 secant theta is going to give me secant theta, and then tangent theta I already had. So notice that these 3 terms match up with these. So basically what I can do is I can split this into 2 fractions. I can do this over this and this over this. I don't think this is going to work. If I do all of this over this, they're identical, so I get 1. And then I get plus, now I do this, 2 secant theta minus 2 over that big old ugly thing, tangent theta minus secant theta plus 1. I don't see us getting any closer to that right now. That'll be, I'm just thinking out, that'll be 2 minus 2 cosine, and then sine minus 2, or minus cosine, or minus 1 plus cosine. Man, I don't see that. All right, that's not working. This is, I'm hung up. This is good. Number 61. Let me just see what this is real quick. This right here, sine theta over cosine theta plus 1 over cosine theta, which is really sine theta plus 1 over cosine theta. That's what my right side is. Right? Let me mess with this a little bit. What if I multiply this by 1, but I do sine theta minus 1 over sine theta minus 1? And when I do my foiling out up here, I'll get sine squared theta minus 1 over cosine theta sine theta minus 1. I could rewrite sine squared with the Pythagorean identity That's 1 minus cosine squared theta. Yeah, no. Okay. All right, I'm going to leave that right there. Man, it's got to be something. I'm not seeing it. It's the three terms that's really making this messy. So I'm going to go back to good old faithful and rewrite this sine theta over cosine theta. I'm going to get this. It's just going to be, I'm going to have a moment here where I'm like, ah, I got it. That's kind of what you're looking for at home. And it's good probably to see me struggle with this a little bit. That's why I don't like to work these problems out beforehand. I like for you to see the struggle if I run into an issue. All right, that's what I had done initially. And when I multiplied through by cosine, let me just make sure I did that multiplication through first. When I multiplied by cosine on the top, I got sine theta. Multiply cosine here, I get plus 1. Multiply cosine there, I get minus cosine theta. And all over, multiply cosine here, I get sine theta. Then minus, multiply cosine here, I get 1. Multiply cosine there, plus cosine theta. And I'm trying to get to this. This is going to be very unnatural, but let me see this. Sine theta plus sine squared theta plus cosine squared theta minus cosine theta. So what I did is I rewrote this 1 as sine squared theta plus cosine squared theta. And then over sine theta, then minus, now I'm going to rewrite that as a 1 again. It's going to be minus sine squared theta, minus cosine squared theta, and then I have plus cosine theta. So again, what I did there is this right here by itself, the 1 is sine squared theta plus cosine squared theta, but then there's a negative, so it distributes to both. Now, does this help me at all? I could try and factor out 1 plus sine, 1 minus cosine. Jeez. What I was thinking here was sine theta out of the first 2. And then I could take a cosine theta out of the second 2. And then over, I could pull a sine theta out of the bottom 1 minus sine theta, and then I could pull a cosine out of the next one. I'll pull a positive cosine out, and I'll be left with 1 minus cosine, or let me pull a negative cosine out, and I'll be left with a cosine theta, and then minus 1. But that still doesn't help. I can't cancel these. Gosh, it's got to be something simple. It can't be this complicated. It really can't. And this is what's really frustrating about these problems sometimes, is that you get to a point where you're stuck and you really don't have any, you've tried exhausting different things and you can't really come up with anything. So sometimes you have to just sit back relax and try something else. I think what I'm going to do is I'm going to let my brain take a break on this one, and I'm going to move on to number 63, or no, yeah, 63, and then come back to this one. Maybe after I do 63, I'll feel better about that one. Interesting. Okay, 63, tangent theta. So this is what I would do. I mean, like if I were you, if you get stuck on a problem, just move on to the next one and see how you do. Plus cotangent theta equals sine squared theta minus cosine squared theta. Okay, make sure I got that written down right. All right. I'm going to start with the left side. See, I only have 2 terms here now, so I'm feeling good about that. When I see three terms, that's when things start getting kind of messy. So let's see, we do sine theta over cosine theta, and then minus cosine theta over sine theta. That's just rewriting tangent minus cotangent. Then all over sine theta over cosine theta, that's tangent, plus cosine theta over sine theta. And let's go ahead and get a common denominator on the top. So when I do a common denominator, I'm going to have to do sine on top and bottom here and cosine on top and bottom here. So when I do sine on the top times the sine, I get sine squared theta. And then when I do cosine on top and bottom here, I get cosine squared theta. And this will all be over the common denominator, sine theta, cosine theta. And there will be subtraction between the two. So I'm trusting that you could put sine here, cosine here, together, and then put them all together like this. Now on the bottom, we do the exact same thing. We do sine here, cosine here. We're going to get sine squared theta this time plus cosine squared theta, and then all over our common denominator, sine theta, cosine theta. And now when I do my fraction over fraction in flip, like this, the sine theta, cosine theta comes up top, and then the sine square, oh, well, this is 1. So let's just say that's 1 right there. And this sine theta, cosine theta cancels. And all you're left with is this right here, which matches that. So look, 63 went without any issues. I still am not ready to go after 61. How about 69? 1 minus tangent squared theta over 1 plus tangent squared theta plus 1 equals 2 cosine squared theta. Make sure I wrote it down right. I'll start with the left side. Well, here's what I know. That's 1 minus tangent squared theta over secant squared theta. Because 1 plus tangent squared theta is secant squared theta. So I've got that. And now what I'm going to do is I'm going to get a common denominator. So I'm going to turn this 1 into secant squared theta over secant squared theta and put them together. So I've got 1 minus tangent squared theta plus secant squared theta all over secant squared theta. And I think good things are about to happen on the top. Let me replace secant squared theta right here with the Pythagorean identity. That is the same as 1 plus tangent squared theta. So if I put that right here, I'm going to get 1 minus tangent squared theta plus 1 plus tangent squared theta. So I'm going to have the 1 plus the 1, that's 2. The minus tangent squared theta and the plus tangent squared theta cancel, so I just have a 2 up top. and then I have secant squared theta on the bottom. That's the same as 2 times 1 over secant squared theta. And the reciprocal of secant is cosine. So this really is cosine squared theta. So we get 2 times cosine squared theta. Again, that one went pretty easy. $75. 1 over 1 minus sine theta plus 1 over 1 plus sine theta is equal to 2 secant squared theta. What's funny is that number 61 that I'm hung up on, I did that in class last semester. Don't know why I'm getting messed up on that. Okay. I'm still thinking about 61. Okay, back to this. I'm going to put these two together with a common denominator. So when I do that, I've got to do 1 plus sine theta here, 1 plus sine theta here, 1 minus sine theta here, 1 minus sine theta on the bottom there. Okay? So my denominator on the left side is going to be 1 plus sine theta times 1 minus sine theta. That's my common denominator. And then my numerator is going to be this times 1, which is 1 plus sine theta, then plus 1 times this, which is 1 minus sine theta. And the sine thetas cancel, and you've got a 2. That's good. I've got a 2 over here. Then on the bottom, if you FOIL this out, you should get 1 minus sine squared theta. And that's cosine squared theta. Pythagorean identity. And then cosine squared theta on the bottom can come up as secant squared when you do the reciprocal function. So we are there. 77. I'm going to be angry when I get 61, and I'm going to be equally satisfied when I get 61. All right, secant theta over 1 minus sine theta equals 1 plus sine theta over cosine cube theta. Where'd that come from? It's the first time we've seen that. So when I'm looking at this, I'm thinking this might be more complicated, but I think I'm going to try and work with this side, because I need to end up with the 1 plus sine theta on top. So if I multiply the top and bottom by 1 plus sine theta, I know on the bottom I'm going to get something good happening. So let me try that. I multiply the top by 1 plus sine theta times secant theta, and then over 1 plus sine theta. I'm multiplying that on the top and bottom. There is already a 1 minus sine theta there. So on the top, I'm not going to distribute that. Watch. 1 plus sine theta, it's going to leave it alone. Secant theta. Now I'm thinking to myself, secant theta is really 1 over cosine, so there's a cosine that's going to drop down here. When I do this thing here, I'm going to get my 1 minus sine squared theta, and that's cosine squared theta. So I have 1 plus sine theta, then I've got my secant theta, and then on the bottom I've got cosine theta, cosine squared theta, Pythagorean identity from here to here. And look, I'm so close. 1 plus sine theta, I've got it. Cosine squared, I've got it. Just the secant. So just scratch the secant and write it as 1 over cosine theta. And now you've got your cosine cubed theta. And you got the 1 plus sine theta on top. So that's it. All right. $79. All right, parentheses, secant v minus tangent v squared plus 1, over cosecant v parentheses secant v minus tangent v, close parentheses, equals 2 tangent v. Oh my goodness. All right, let me go. Let me do it. Start here. I'm going to just square this. So if you multiply this times itself, you should get secant squared v minus 2 secant v tangent v plus tan squared v, and plus 1. So I trust that you can take that, FOIL it out with itself, collect like terms. You should get these three terms for squaring that, then the plus 1. Then all over, cosecant v times secant v. Let me talk about what that is. Cosecant v times secant v is really 1 over sine v times 1 over cosine v, right? Like that. I'll leave it the way it is. I'll just leave it as cosecant v times secant v. And then I have minus cosecant v times tangent v. And my gut's telling me I should not have multiplied that through. My gut is telling me I should not have multiplied that through, but I think I can just pull it out on the next line if I need to. I'm seeing something here, tangent squared v plus 1, that's secant squared v. And I already have a secant squared v out front, so this plus this one, because it's addition, that's 2 of them. So I've got 2 secant squared v's minus 2 secant v tangent v over, yes, I'm going to pull that thing back out. Cosecant v parentheses secant v minus tangent v. The reason I pulled it back out is because I can see up top I can pull out a 2 secant v. I pull out 2 secant v out of the top. I'll be left with a secant v here minus, and then here I'll just be left with the tangent v. And that's what I was hoping to happen, something like that. This is cosecant v, and then I have secant v minus tangent v on the bottom. Perfect cancellation. And then remember, I'm trying to get to tangent over there. So this is 2, I'm going to pull the 2 out front. Secant v is 1 over cosine v. And cosecant v on the bottom flips up to really become sine v on the top. And this is sine v over cosine v, which is tangent v. So you have 2 tangent v. Interesting. Wow, it's almost 2. $79, done. $83. Sine cubed theta plus cosine cubed theta. In my mind, I just thought sum of cubes formula. I have 2 cubes that are being summed together there. And then that equals 1 minus sine theta cosine theta. Oh yeah, this is going to work. All right, so I need to remember a formula. X cubed plus y cubed equals x plus y times x squared minus xy plus y squared. This is a sum of cubes formula from college algebra. So 2 things cubed being added together, here's the formula for it. So I notice I have 2 things cubed being added together, so I can rewrite that as the first one plus the second one. So that's going to be sine theta plus cosine theta, and then times the first one squared, so sine theta squared, sine squared theta, minus the 2 things multiplied together, so sine theta cosine theta, and then plus the last one squared, which is the cosine theta, and I'm going to square that, so cosine squared theta, all over sine theta plus cosine theta. Oh wow, look at that. Gone here, and then these 2 right here are the Pythagorean identity. Sine squared theta plus cosine squared theta is 1. So this is 1, take away this, and that matches the right side. Man, 83 just smooth as could be, as long as you have that sum of cubes formula. $91. I'm getting there. 91 just looks bad. Okay, 91. You have letters A sine theta plus B cosine theta squared plus A cosine theta minus B sine theta squared equals A squared plus B squared. Oh, wow. This, I think, looks worse than it actually is. How are we doing on markers here? Need some fresh ones. All right, I'm going to square this. So I'm going to multiply it times itself. A sine theta plus B cosine theta times A sine theta plus B cosine theta. So I'm multiplying it times itself, and then I'm going to FOIL. So when I multiply this times this, I get A times A, which is A squared, sine times sine, which is sine squared. Okay? Then I do this times this. I get the A times the B, which is AB. I get sine theta and cosine theta multiplied together. When I do the middle one, I get another A times B, and I get another sine theta, cosine theta. And then when I do the last ones together, I get the B times the B, which is B squared, and then I get the cosine squared theta. That's just this squared. And I can clean this up. I'm going to get back to this one in a second. This is A squared sine squared theta plus 2AB sine theta cosine theta. So I put these two together because they're like terms. And then I still had plus B squared cosine squared theta. Now be careful. You cannot put the cosine squared and sine squared together and turn it into 1 because this one has a B squared in front and that one has an A squared in front. However, the other multiplication of this, when I do that and I FOIL that out, it's going to look almost identical to this one, except I'm going to have a minus and a minus. So it's going to look like this. Well, not identical because this is cosine first, then the sine. So when I do this, you'll just have to do that on your own. You should get A squared cosine squared theta. Then you'll get the minus 2AB sine theta cosine theta. And then your last term will be plus B squared sine squared theta. So again, I'm leaving this to you to FOIL out kind of like I did here. And when you take a step back from this, you'll see that this and this cancel. Then you can see that if I take these two right here, they both have A squared in front. I can write that as A squared sine squared theta plus A squared cosine squared theta. And then if I take this one and this one, they both have B squared in front, and just put those side by side. I'm going to put the sine squared first. I'm putting this one and then plus this one. Then out of these two alone, you can pull an A squared out. And you'll be left with sine squared theta plus cosine squared theta, which is 1. So this is A squared times 1. Plus, now here, pull a B squared out. You'll be left with sine squared theta plus cosine squared theta. This again is 1. So I have B squared times 1, which is B squared. So I have A squared plus B squared, which is the right side. '93. Tangent of alpha plus tangent of beta over, I'm still recording, yes, okay, cotangent of alpha plus cotangent of beta equals tangent of alpha, tangent of beta. So they're using different variables here. Instead of theta and v, they're using alpha and beta. Well, I'm starting with the left. I think the left is got more stuff to work with here. This right here, sine alpha over cosine alpha, plus this one right here, sine beta over cosine beta. Then the whole thing over, cotangent is a reciprocal of tangent, so this is going to be cosine alpha over sine alpha plus cosine beta over sine beta. All right, so that's my left side. And I guess I need some common denominators here. So if I want to put these two together, I've got to introduce cosine beta, that's this. On this one, I've got to introduce cosine alpha over cosine alpha. And then on this one, I need to introduce sine beta over sine beta. And on this one, I've got to introduce sine alpha over sine alpha. Oh, man. All right. So when I put these two together, I know that the common denominator is going to be cosine beta, cosine alpha. Question is, what's on top? So I've got sine alpha cosine beta plus sine beta cosine alpha. Let's see if I can write that. Sine alpha cosine beta plus sine beta cosine alpha. Okay, that's my top of that one. And then on this one, same kind of story. I'm going to have sine beta cosine alpha. Let me go sine beta, sine beta cosine alpha. And then another plus. And then here, this is going to be sine alpha cosine beta. Then all of that over the common denominator, which is sine beta sine alpha. And I've got a fraction over a fraction, so I will flip this one. And when I flip it, this comes up top, sine beta sine alpha, over this right here, which is sine beta cosine alpha plus sine alpha cosine beta. And this is now gone. And I believe these two match. Let's check. Sine alpha cosine beta plus sine beta cosine alpha. So these are identical. They're flipped order, but they're identical. So this and this cancel. And what I'm left with here is this on top, sine beta sine alpha over cosine beta cosine alpha. And look at this. Sine beta over cosine beta is tangent beta. And sine alpha over cosine alpha is tangent alpha. So this is tangent beta times tangent alpha. Checks out. All right. I have one more, and then I've got to get back to 61 and see if I can't figure it out. So 95. All right, parentheses, sine alpha plus cosine beta squared plus cosine beta plus sine alpha, parentheses again, cosine beta, this is just torture, minus sine alpha equals 2 cosine beta times sine alpha plus cosine beta. All right. I'm going to start on the left side. So I'm gonna actually FOIL that out, like multiply this times itself. And since I've done that several times, I'm just going to write what it would be. Okay, so that's what you would get if you expanded that. Now I need to do this one. Here, 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 here. So cosine beta and cosine beta, that gives me a cosine squared beta. Here times here gives me a minus. Oh, those are identical. Okay, the middle terms are going to go away, I think. So sine alpha, cosine beta. And when I do this one right here, I get a plus sine alpha, cosine beta. Those will go away. And then my last one, I'm going to have a negative sine squared alpha. All right, so these are gone. Ooh, look, sine squared alpha, they're gone. And I have a cosine beta, cosine square beta, cosine square beta together. Add those, we have 2 of them. So this should be 2 sine alpha cosine beta plus 2 cosine squared beta. And I'm trying to get to this right here. And I think I'm there because I can pull a 2 and a cosine beta out of both of those. And I'll be left with, if I pull a 2 cosine beta out here, I'll be left with a sine alpha. And if I pull a 2 cosine beta out of this, I'm going to be left with a cosine beta. And that's this. Okay. All right. God, number 61. Back to 61. I still don't know what I'm going to do. All those other problems did not help me think of anything clever. Okay, I'm going to just sit here for a minute and take a look at this. Okay, I think I have a way of doing this, but I'm wondering if there's something more efficient than what... I'm just surprised this problem appears in this homework set because it is really kind of a different... It's not a different approach, just very, very unlike all the other problems. I mean, let me just try it and see what happens. So, one thing I could do is I could possibly group these two together and then just multiply the top and bottom by the conjugate of this thing, which would be this expression minus 1. So I could try this. Man, like I said, this is so different than anything else they've asked you to do that, yes, it's fair algebra, but it's just really off from everything else that we've seen up to this point. So that's a 1, okay, but it's like the conjugate of this. All I'm doing is changing that to a minus. And then we just kind of see what happens. And man, I really don't like this, because you have to do all of this times this, right? Now let's talk about the denominator. What happens in the denominator, because that one's easier. You're going to do this whole thing times this whole thing, which will be that whole thing squared. So tangent theta minus secant theta, that whole thing squared. And then the middle terms will cancel. So if you do this times 1, you get one of them. And if you do negative 1 times this, you get them to cancel. And then your last term will be just minus 1. So that bottom is easy to calculate. The top one, on the other hand, let me put this in parentheses like this. And what we'll do is we're going to do this whole thing times this, which will give us tan theta minus secant theta times tan theta plus secant theta. Because they're not exactly the same, I can't say it's squared. Like this one has a minus, that one has a plus. Okay, so that's that. Then I do this times negative 1, so I've got minus this. So it's become minus tan theta plus secant theta, because the negative goes through to both of those. Then I do negative 1 times that, which again, we'll change that. That'll be a minus tangent theta, and then I'll become a minus secant theta. So that takes care of that multiplication. And then finally, this times this should give us plus 1. All right. Now, I do have some secants that canceled here. I have negative 2 tangents, but now let me go ahead and figure out what this is. So because there's a minus here and a plus here, when I multiply those together, I should get tangent squared theta. I should get the outside terms, and the middle terms will cancel. I'll get a minus secant squared theta. Okay, so that's this. I still had minus tangent, so that's minus 2 tangent theta. And then I still had a plus 1 out there. And that's all over. Now on this one, on the bottom, this right here, if I square that, they both have minuses, so that becomes tangent squared theta minus 2 tangent theta secant theta. And then the last one will be plus secant squared theta. And then I still have a minus 1 there. Wow, okay, this has some hope, okay? This does have some hope. What I see I can do here is that I could change this right here. I could change this into something with secants. Or I could change this with something in tangents. I think I'm going to go with tangents, and the reason why is because I've got tangent squared here, I've got a tangent here. So let me rewrite secant squared. Remember, 1 plus tangent squared theta is secant squared theta. So if I rewrite this, replace this with this, it's going to become minus 1 and minus tangent squared. I think I'm going to get there with this. I'm going to leave that up there. That's where I'm trying to get to right there. I think it's going to go. So this equals, again, tangent squared theta we had. And then this minus secant squared theta becomes minus 1 minus tangent squared theta. Now I still have minus 2 tangent theta. And then I still have plus 1. This is what I'm trying to get to. Okay, and then over all this junk down here. Now also pay attention to this secant squared theta minus 1 down here. If I were to bring this 1 over, become minus 1, that's tangent squared theta. So this right here is tangent squared theta. So my denominator is tangent squared theta here, and then minus 2 tangent theta secant theta, and then I have plus tangent squared theta. I think this is going to go. I think this is going to go. Yes, yes, I see it. I see it finally. Okay. All right, these ones cancel. I have these tangents cancel. And so my numerator, all that's left is negative 2 tangent theta over my denominator, which I have tangent squared theta, that's 2 tangent squared theta, and then minus 2 tangent theta secant theta. Oh my goodness, it's still not pretty. Now I can factor out of the denominator a 2 or a negative 2, and then I can also pull a tangent out. So I'm going to say negative 2 tangent theta over, yeah, let me pull a negative 2 out. Negative 2 tangent theta is what I'm pulling out of the bottom. So if I pull a negative 2 tangent theta out of there, I'm going to have a negative tangent theta. So if I multiply this times this, I get back this. And then here I'm going to have a plus secant theta, like that. And now these cancel, and you're left with 1 over, I'm just going to switch the order of those, secant theta plus tangent theta. Okay, that is not this. That is not that. But I've got at least 2 terms, so I think at this point I'm going to turn everything in terms of sine and cosine. I've got to be there. I've got to be getting close. Come on, come on. But that's the reciprocal. Okay, let's go with this. This is 1 over, secant theta is 1 over cosine theta, plus tangent theta, which is sine theta over cosine theta. And if I put those together, this is 1 over 1 plus sine theta. Putting those together over cosine theta. And then 1 over a fraction, you flip it, and it becomes cosine theta over 1 plus sine theta, like that. Still not there. So I'm going to multiply the top and bottom by 1 minus sine squared, sine theta, 1 minus sine theta, which is the conjugate of the bottom. And so I get on the top cosine theta times 1 minus sine theta over the bottom. When I multiply that out, I get 1 minus sine squared theta. And then I can do the denominator is cosine squared theta. I've messed up. 1, this is cosine theta. So this becomes 1 minus sine theta is left on top over cosine theta, which is split in 2 fractions, 1 over cosine theta minus sine theta over cosine theta, which is secant plus tangent, minus tangent. I screwed something up. I screwed something up. My sign's off somewhere. My sign is off somewhere. Crikey! This is a great problem. I hate it, but it's a great problem. I have to start over because I messed up a sign somewhere. All right, I'm doing it again. Tangent theta, be very careful here, plus secant theta. Put that in parentheses, and we had minus 1. That's the numerator. Over the denominator, which was tangent theta minus secant theta plus 1. Now I know where am I trying to get this to? Tangent theta